Hello everyone, this is Raymond Burchard, and this is my final presentation for my climate control for a plant cabinet project. In this presentation, I'll give a brief introduction to my project, then I will discuss my initial proposed design and my final design. I will go over the results of my project as well as my design constraints and standards that I followed. I will show a list of components and my budget for the project. My interest in plants started in 2020 when I was off of work due to COVID-19. I needed to make a change in my house because I was there all the time, and I chose to put a few houseplants around. This grew into a bigger hobby, and soon I was spending a lot of money on plants. I decided that I would sell some smaller plants to help fund the hobby. I found that there's a good market for houseplants and that selling cuttings and propagations can be a good way to make some extra money. When I started this class, I had to choose a project, and it seemed like a natural fit to make something that helped me with my plant hobby. I designed this system to help keep track of the environment inside the cabinet where I kept some of my most expensive plants. For the system, I need to track three different conditions: the temperature, humidity, and soil moisture. These are the most important factors for growth inside the cabinet. In my original design, I had a fourth system that would be responsible for managing outputs of the other three systems to have a more refined display. I decided that this wasn't necessary and would not be a time and cost-effective addition to the project. For the temperature system, I used this temperature sensor. It has a single probe with a single output that was perfect for what I needed. I attached a blue LED to the output to indicate that the temperature inside the cabinet has fallen below my target set point. For the humidity system, I used a quad op-amp LM339 and an HIH4030 humidity sensor to trigger three LEDs at varying levels of humidity. The system works by using resistors and the signal to the op-amp from the humidity sensor to turn on the LEDs at different humidity levels. This system works really well and is only designed to show ranges of humidity. This works for my needs because I need to keep the inside of the plant cabinet above 75% humidity. The soil moisture system is designed to help me know when a plant needs to be watered. It will also help when making soil compositions. A lot of plants need to have soil that doesn't hold water like normal dirt. I use many compositions of soil components for different plants. This system will help me by giving me something to measure when making new compositions. The system works by using a 555 timer to switch between two LEDs. The system will test the resistance of the soil, and the more moisture is in the soil, there will be less resistance. With less resistance, the capacitors in the circuit will cycle faster, which causes the LEDs to switch faster. My final design didn't vary much from my initial proposed design. I did a lot of research to finding circuit designs that worked for my needs. I built and tested them without any major issues. To test the circuits, I put them in an environment that allowed for a change of state for the outputs. Then I used a fluke temperature and humidity meter to make sure the sensors were detecting the appropriate value. I put the circuits on miniature breadboards that could be snapped together without having any electrical connections. I used mounting tape to mount the breadboards and the temperature sensors together. I put the step downs from the humidity and soil moisture systems at the top of the enclosure where they'll not be readily visible because they don't give any information about the cabinet. In the picture, you can see how I mounted the circuits and how the enclosure is mounted on the cabinet. After fully installing the system, I watched for any change in the cabinet. You can see a clip of the function on the right side of the screen. Outside of a few minor temperature fluctuations, there were not any problems that were identified. This is not surprising because it's summer and the plants like the heat and humidity. The soil moisture system is functioning really nicely, and I have placed the probes in several different plants to see the difference in moisture drainage. This will be very helpful in the future. For this project, my major constraints were the size and the effectiveness of the system. I didn't want the system to take up any room inside the cabinet, and so I decided on placing all but the probes outside the cabinet. I didn't want the system to take up too much room on top because I use that area for storage also. My final enclosure is larger than what would have been ideal, but I would like to build more functionality into the system to make the size effective. The standard that I looked at for this project are the NFPA 70E Safety for Electrical Work standards, and specifically the NFPA Article 406.9, which covers working with electrical plugs in moist or wet environments. To meet this standard, I used a GFCI outlet and waterproof power supply. Here is a list of components. I have added the cost of the enclosure to the table. The enclosure was only $45, so I'm still well under my $200 initial budget. So my system is installed onto the cabinet and the entire system is functioning properly. I'm happy with how the project turned out. I'll be using the system for the next few months and will document the number of times that something goes wrong with the cabinet. I will use that data to determine that the system is actually making a difference. And here's my list of references. Thank you.